Hello, welcome. Let's continue to solve another Leetcode problem 416. Partition equals subset sum. So we are giving an array nums. Inside the nums, it's gonna be the positive numbers. As you can see it, the nums length is 200 and nums I is from 1 to 100. And we can return true if we can find partition. We can partition the array into two subsets. So the partition just means we can find like 1, 5, and 5 is equal to 11. So this 11 is the half of 22 because the sum of them will be 22. So it means we've already found a solution. So we're gonna return true. Otherwise, if we didn't find, we're gonna return false. So this is a typical 0, 1 knapsack problem. So for each of the time from index 0, we're gonna choose it or not choose it, and then for the second index and third index and the last index, we can decide to choose it or not choose it. But finally, we just need to check, if some of the values can sum up to the total of nums divided by 2. Now let's try to write the knapsack first. And then if I need some variables, I'm gonna add it. So for me, while I'm writing knapsack, I'm gonna always use a function. Inside of the function, it's gonna be f. So this f is just a DFS function because I'm gonna use the memorization. Because this is easy to understand. So inside of the f function, I'm gonna use a total value. This t gonna be starting from 0, and then I'm gonna use an index I. So this index I will also be starting from 0. So I'm gonna call this function f from 0 and 0. Now I'm gonna need to check something. Check the boundary case. So what is the boundary case? Normally for the 0, 1 knapsack and for my template, it's gonna be I for I equal to the length of nums. So this means if I go out of the boundary, I need to check something. If it is a true or false, according to this problem, it's going to be a true or false. So I need to check it. If my index goes out, I need to check if I find a result or not. So I need to check. So if this t equals to the half, let me name a half. I'm going to write this half later. Half is just the total sum of nums divided by 2. If it is equal to half, it means I'm gonna return a true. So I'm gonna return true. Return true if I find it. So if this t equal, else I'm gonna return a false. Now let me write if it is not equal. So I'm gonna execute the DFS, basically the f function. So I have two decisions. I can choose it or not choose it. If I didn't choose it, so it's gonna be t I plus 1 because I need to go to the next index, next item. Or I can choose it. So if I choose it, so d would plus this nums I, and the I would also be the same because it is a 0, 1 knapsack. I can only choose one time. It is not unlimited. It means I can only have one time to decide, choose or not choose, and then go to the next. This is why I use I plus 1, as you can see from here. So basically this is the total function, but I need to know a half. Let me just write the half. Would be sum of nums and divided by 2. But I need to check if this half is valid or not. So I need to check if this is sum of nums, if it is cannot be divided by 2 if it is divided modular 2. If it is modular 2 equals to 1, it means this is an odd number. It is not possible, so I'm gonna return a false directly. Otherwise, so I have a half value, and now I'm gonna check if it is equal to half or not. Now let me submit it to check if it works. Oh, there's some problem. Let me just check why this is wrong. I returned a number. Oh, this is why. Because for here it is not plus. I need to use or. Because this or is basically to check if there is a true. If there is a true, definitely I'm gonna return a true. So that is why here gonna and this one is just the different solutions, and here is also different solutions. So while executing this DFS or this f function, it's gonna be a lot of true and false. If there is a one true, so finally I'm gonna return a true. Yeah, now let me edit and submit it. Yeah, as you can see, it works and it's pretty fast. Yeah, even though it is slower than the tabulation, but I think for the memorization, and it's gonna be for the top-down solution memorization, it's gonna be easier to understand. At least you know how to start from the problem. It is 0, 0, and then until you go to the end and get the final result. Yeah, I believe this is gonna be easier to solve the 0-1 knapsack or the knapsack problem. Yeah. Now let me summarize. The time complexity is just t times I, because there is a cache. Everything is inside the memory. And let me summarize a little bit of the similar problem. Actually, yeah. So for the 0-1 problem, basically there is a template. So the template is we also have the value array and we have the weight array. Basically, we need to check the maximum value we can got if we have a limit of the total weight. Yeah, as you can see, it is like this. And for the target sum, it is also 0-1 knapsack problem. Yeah, basically every knapsack problem gonna be the same. For this problem, partition equals subset sum. Yeah, actually it is the half. We just need to calculate the half and then decided to choose it or not choose it. Here is also choose it or not choose it. Actually, this is gonna be really easy for the 0-1 knapsack problem if you use the memorization solution. Yeah. Now let me go back and check the result. So the nums array is just 200 and the nums I is 200. So it seems the time complexity will be just 200 times 100, I believe. Yeah, so that is why it is so fast. Thank you for watching. See you next time.